In this problem, we are finding the linearization of a trigonometric function. And just as a way of review, what is a linearization? Well, let's say you've got some trigonometric function bouncing around like this. You can find the equation for a line tangent to the function at some point. That's called the linearization. Why do we do that? Because, you know, around that point, very close to that point, this tangent line is a pretty good approximation of the function. And it's a much simpler thing to compute because it's just the equation for a line. So nearby in that neighborhood, sometimes the equation of the line is a good enough substitute for the equation of the function for figuring out the values that you have there. So to find a linearization from a function, we're going to rely on the fact that the slope of the tangent line is the same thing as the derivative of that function evaluated at that point. So we're going to take the derivative of this function first. That's going to give us the slope. We're looking at linearization for this function at the point 0. And then all we'll need is a point, and we can get a point by taking that 0 and plugging it in to our function. Then we'll have an x and a y value. And once we've got a slope and a point, we can write an equation for this line. So let's start with the derivative. This is actually a fairly complicated derivative here. So we've got a big complex trigonometric thing inside here, but it's all cubed. So I'm going to start by saying, let's use the chain rule. I'm going to start by saying u is the sine of 3x minus pi plus 1. And our new function is u cubed, okay? And the derivative of that is going to be 3 times u squared, and then times the derivative of u. Well, so 3 and u squared is just what's in here squared, so sine of 3x minus pi plus 1 quantity squared times the derivative of u, so the stuff that's inside. The derivative of the sine is the cosine. We've got a 3 multiplied by the x in here. I mean, you can do substitution or chain rule again. I'm kind of doing this in my head. You could say u or v equals 3x minus pi. The minus pi, you don't have to worry about because it's a constant, but the 3 is going to come out. And this is going to be 3 cosine of 3x minus pi. And that 1 also disappears because it's a constant. So it when you take the derivative, it goes to 0. Okay, so this should be the derivative. This is f prime of x. And we're going to use this to find the slope at 0. I'm glad it's 0 because this is going to be fairly easy to calculate, I think. So if I put in a 0 here, well, let's write the whole thing out. 3 times 0 is 0. So this is just the sine of negative pi plus 1. Oops, I forgot a parentheses there. And then quantity squared. And then this also is a 0. So this is just 3 times the cosine of negative pi. And if you think about the unit circle, negative pi is the same as pi if you just go around in this direction. And the coordinates there are negative 1 comma 0. So the sine of negative pi is 0. So this is 3 times 0 plus 1 quantity squared, which is just 1, and 1 squared is 1. So this is all of this just comes out to 3. And then the cosine of negative pi is negative 1. So this is just 3 times negative 1. So we've got 3 times negative 3, or a negative 9. Now this, we're computing the derivative at the point 0. So the slope of that tangent line at point 0 is negative 9. So our slope is negative 9. Okay, now we need a point in order to make a line, an equation for this tangent line. And I'm going to do that by taking our point 0, because I know it's on the line, because that's what we just figured the derivative for, and put it in this function. So that point is where the line and the function touch. That's the tangent. So let's go ahead and figure this out at 0. So again, this part is 0. So I get the sine of negative pi plus 1, and we get that quantity cubed. Well, the sine of negative pi is 0, so 1 cubed is 1. This just equals 1. So the point 0, 1 is on here. And if I put that into the point slope form, I'm going to get y minus 1 equals negative 9x minus 0, but I don't need to put a minus 0 there. And we're going to add 1 to both sides, and I get y equals negative 9x plus 1. That is the equation for that tangent line, that linearization. So y, oh, do they just want the minus 9x plus 1? I think so. The L of x is the, yeah. So minus 9x plus 1. So that is a little bit of work with finding a linearization for a trigonometric function.